Okay, U-substitution. So when we take integrals, the only thing that we've learned up to this point is the power rule, right? If we have an integral like, I don't know, let's say it's 2x, you don't have to write this down, but let's say it's x squared plus 4. We don't know how to do that yet, right? Unless we were to, the only way we would know how to do this is to write this out 7 times, multiply it, like FOIL it through 7 times, it has this enormous function, and then take the integral of that. We haven't learned anything, like when we did derivatives, we had chain rule, we had product rule, we had quotient rule. So U-substitution is kind of like a reverse chain rule for integration. It allows us to do stuff like this when we can't just like easily do the power rule, okay? So like square roots, cube roots, like raised to the 7th, 2nd, 3rd, whatever, so you don't have to multiply everything out. This is kind of like the official rule for U-substitution right here. So I think if you write this down, if you happen to have like 2 highlighters or a highlighter or 2 different colored pens today, I think if we color coordinated things, it would make things a lot easier. It's not necessary, but if you have it, it would make things easier in your notes. And so U-substitution is really just the reverse chain rule for integration. All right. Okay, try to explain what this means on the next slide when you guys are ready for it. Can break it down into a handful of steps here. So steps for U-substitution. Choose what U is, which is always going to be like the inner part, the higher power part, the denominator, whatever's under the root, like kind of like the inside function. Whatever's in parentheses under the root is what you're going to label U. Du is just the derivative of U. There's a couple more steps under this. One more step down here. So there's our step 5. It probably doesn't make a ton of sense right now, but once we do a couple problems, it'll hopefully clear up. All right. Again, you don't have to write any of this down, but let's go back to that like hypothetical example that I gave you before. Like, we don't want to expand this out 7 times and multiply it through. U-substitution is just what it sounds like. You substitute a U in for like the biggest part of this. So this is essentially the same thing as writing it like this. Okay, it's a little bit more involved than this because you have like a du going on and everything like that. But this is essentially what you're doing. You're taking the biggest part or the biggest part of the function and substituting in a u and then taking the antiderivative of that. So let's do a couple examples if we're ready. Okay, can always jump back to this if you need me to. So let's do the first one. It says integral of x squared plus 1 squared 2x dx. This is where if you have different colors, I'll start to underline or highlight different colors up here. Okay. You have to make sure that every part of the problem is accounted for. So I'm going to take what's inside the parentheses or inside the highest power, and I'm going to call that my u, and I'm going to color that or just underline that in blue. So let's call u x squared plus 1. Okay, again, whatever's under your highest power, whatever's under your radicals, that's what you want to call your u. Okay, and your next color, so that only takes care, I'm substituting in u, I'm still forgetting about these two things that are going on at the end here. So we still need to account for our 2x dx. So our u accounts for our blue, our du is going to account for our 2x, because if I take the derivative of u, which is du, the derivative of this becomes 2x, right? X squared becomes 2x, and then I have with respect to x after it. Okay, so derivative of x, or x squared, becomes 2x dx. Okay, and in these first couple problems, when you take the derivative, it's going to match what we have here. Okay, so these are kind of like the quicker problems. So then when you rewrite this, this becomes integral of u squared du. Okay, because this was your u squared, and then this was your du that you accounted for. Okay, now this is something we can easily take the antiderivative of, right? We don't have to expand anything out or anything like that. This just becomes u to the third over 3. Now, it's an indefinite integral, so we need to have a plus c at the end. That's something that we don't want to forget. And your last step, I think it was step 5, just said plug in your original variables, your original function in for u. So now that I have the antiderivative, instead of u to the third, I can plug this back in and say x squared plus 1 to the third over 3 plus c. So it's like swapping out and then swapping back in. Okay. All right, let's do a couple more. Do one trig one. Yeah, let's do 5 cosine 5x dx. All right, I'm going to show you guys later in class what to do if there's like multiple trig functions, but for now we're just going to focus on like if you just have a cosine or a sine. Again, just follow that same protocol, like whatever is inside those parentheses is going to be your u. So let's call u 5x. And let's call d, so if I take the derivative of this, derivative of 5x is just 5 dx. So again, with respect to x. So that covers this, and that covers this. Okay, so if I were to rewrite this, I'd still keep my trig function here. I would just say the antiderivative of, this would be cosine u du, and let's just make sure we have everything covered. This is my u, this is part of my du, this is part of my du, so everything should be covered from the original problem. We don't want to leave anything out. Okay, and at that point, you just take the antiderivative. So this is going to be sine u plus c, which u is 5x. That would have been your final answer. Any questions up to this point? We're going to take it a step further next. Okay, now what happens? So let me jump back before we write this down. On both of these examples, notice that du worked out perfectly. It matched whatever was left over in the original function. All right, same thing here. Du worked out perfectly, so it matched whatever was left over. What happens when the derivative is not exactly in the integral? Okay, so let's do one. I'll do one with you, and then I'll have you try one on your own. Let's do this one together. So again, if you really wanted to, you could like write it out 3 times, FOIL it, you get the same answer, but this is, U-substitution is way quicker. So I'm going to take what's inside my parentheses and I'm going to call that u. So let's say u is 5x squared plus 4. Okay. Now, if I take the derivative of that, this is going to be 10x dx. Okay. As of right now, that covers my dx. But 10x is not x, right? We're missing, like we got to change something here. Anybody have any ideas? They throw random ideas out there. No stupid opinions. Okay. If they don't match, get them to match. So if I want x dx to be right here, that means I need to divide this side by 10. Okay, so this 1/10 du is x dx. Now it matches what's left in my or what's left in my original function. Okay, so if they don't match, there's some manipulation that you have to do to du. Sometimes you have to divide, sometimes you have to multiply, sometimes you have to throw in a negative on both sides. You just have to get it to match whatever's over here. Okay, so if I rewrite this, all right, this is where you got to reorganize things, because if I rewrote this, I would be writing it like u 1/10 du, but you don't want to write it like this. You want to write your constant out front. Okay, so let me rewrite it, because you can reorganize it whatever way you want. So I'm going to say antiderivative of 1/10 u to the third du. Okay, so off to the side. And again, just check yourself. The 1/10 du, 1/10 du covers my green. The u to the third covers this blue part. So you just got to make sure that your bases are covered. Now you can take the antiderivative. This is going to be, this would be u to the fourth over, well, let me go one step. I don't want to skip steps here. This would be 1/10 u to the fourth over 4 plus c. So this would be u to the fourth over 40 plus c. And you're pretty much done. You just got to plug in your u at the very end. So this becomes 5x squared plus 4 fourth over 40 plus c. Good so far? All right, you guys digest that for a couple seconds. Okay, all right. Let's see how far, I know this one looks different because we have a denominator, but I just want to see how far you guys can get on your own on a single problem. And this is, I'll do it, I'll give you some time to work through it, and then I'll just start to put the answer up here after a minute or two so you can check.
Hey, Mr. Spiel.
Yes.
On the last problem, how did you get your du 10x dx? I don't know how you got that.
Oh, I took the derivative of u. So u was 5x squared. And then du would be the derivative of that. So 5 times
So
3
wouldn't
is
that be
30.
10x to the third power?
No, remember we're doing derivatives. We're not doing integrals. So derivatives, we subtract 1 from the exponent.
Oh, okay, my bad.
Yep, that's right.
Thanks.
Okay, so if you got to this point, you would have had to multiply both sides by -2 to match what you see up there. You wanted to get to a positive 4x dx, which is what I have right here. So that's good. So my 16 minus x squared is covered. My 4x dx is covered. I just have to rewrite it. This would be, what do we have? Negative. You'd have to write it like this. Okay, the -2 du covers the 4x dx, and you have the u to the 1/2 in the denominator. Which is the same thing as -2 u to the -1/2 du. I'll let you guys finish it from there. this becomes to the positive 1/2. Comes to the positive 1/2 down here. So I just flip the denominator, right? Multiply by the reciprocal to get -4. That one was kind of tough, especially in your first one on your own, because if we had the denominator, we had the root, and you had to bring the exponent up and make it negative. But when we do stations, there's going to be a couple like this, so you'll have practice on it. Any questions, concerns, worries? Need to practice it. All right, see a few people just finishing up, so I'll leave this up here for a little bit longer. All right, so it's 9:15. I wanted to give you guys like 20 or 25 minutes just to walk around and work through some practice problems. It may not even take you that long, but after those 20 minutes, I think we can take a longer, like 10 or 15-minute break. And then after that, we'll figure it out. We'll either do a little AP practice or we'll move on to a little more complicated trig at the end here. We only got like a really short set of notes left. There's only like 1 or 2 problems. Okay. All right. When you guys are doing stations today, I need to try and recommit myself to contact tracing because it's something that's been coming up a lot lately. So I know at the start of the trimester, I always had you guys go on Canvas and go under course information and hit partner sign up. Again, I know it's annoying, but if I get contacted and I get asked who's working with who, I need to have answers for that. So if you're going to walk with someone and work with them on stations, if you could just go to Canvas and let me know who you're working with. Again, it's the very top module. It says course information. That would be greatly appreciated. For stations today, you don't really need a calculator. I guess you could have one if you wanted one, but just a blank sheet of paper, something to write with, something to write on. There are 3 stations in here, and there are 7 out in the hallway, so a total of 10 stations. U-substitution is definitely going to be on your test next week, so please let me know as you're walking around. If you have questions on this, don't suffer in silence. Answer key is on Canvas, so you could do all the work and then come back and check it if you want. Or if you don't want to leave your desk and you'd rather just sit down and work because it's a Monday, all the stations are on Canvas too, so it's your choice. Either way, okay? I'll leave the next 20 minutes up to you guys, and I'll just walk around and help you as you need it. Okay, 3 stations in here, 7 out in the hallway. Those of you at home, same thing. These are posted on Canvas. Answer keys posted on Canvas. I'm going to start the timer now, and let me know if you have any questions. Also, you guys, when we're doing stations here, if you want to be in a breakout room with someone to get to help each other out, just type it in the chat, and I will do that for you. Try to spread out, please. Try to spread out. Two or 3 at the most at a station.